Welcome to online lecture series, Mathematics online lecture series, lecture number 14. Today's topic, change of order of integration in double integrals by Professor K. Winners. So now what is change of order of integration? So we have a double integral. X is a to b, y is some function times of x to some function g of x, f of x dy dx. In this integral, first integrate with respect to y, then integrate with respect to x. This is the double integral. Now change of order of integration is nothing but interchange the two variables. Now first integrate with respect to x, then integrate with respect to y. For this purpose, change the limits in terms of y, x limits in terms of y, phi of y to psi of y, f of x, y dx dy. So in double integral with variable limits, the change of order of integration changes the limits of integration. So if the given integral is in terms of integral x to some a to b, y is g of x to g of x. Now change the order of these two variables. First integrate with respect to x, then integrate with respect to y. Now this method of changing the order is nothing but change of order of integration. Now we will discuss the change of order of integration with problems. First problem. Evaluate the integral by changing the order of integration. Integral 0 to infinity x to infinity e power minus y dx dy. So if you observe this integral, so first limits in terms of y, that's why this is y. Now other variable is x. So in this integral, integrate with respect to y, then integrate with respect to x. Sometimes it is very difficult to integrate with respect to y and then x. For this purpose, apply this change of order of integration. Suppose if method is mentioned, then apply change of order of integration. Otherwise, if it is very difficult to solve the integral, then change the order of integration. First with respect to x, then with respect to y. So in this problem, x is 0 to infinity, y is x to infinity. Suppose if you integrate with respect to y, e power minus y by y it is very difficult to integrate. So for this purpose, change the order of integration. So our method is also change of order of integration. Then how to change of order of integration? First step is find out the region. In this method, first find out the region. Then change the order of integration. Then find out the limits and evaluation of change the limits, then evaluation of the integral. So we have three steps. So first find out the region, then change of order of integration. And also change the limits correspondingly, change the limits with the help of this diagram, and finally evaluate the integral. Now what is the procedure? First, if you observe the lower limit, y equals to x. This is y equals to x is a line. This is y equals to x. Now our limits, y limits x to infinity. Y equals to x is nothing but this one too. Along, sorry, here mistake. This is x. This is y. Sorry, this is y. So y is x to infinity. Y is x to infinity means y equals to x is nothing but this straight line to up to infinity. Line to infinity. This line to infinity. Okay, fine. And also x is 0. X is 0 is nothing but y-axis to infinity. X is infinity. The combined region is the red color region is the combined region. So first step is completed. For the given integral, find out the region. Now change the order of integration. Now, what is the procedure? I will explain here. So in the previous integral with respect to y, then integral with respect to x. Now with respect to x. What about the limits of x? Then limits of y. Now observe x limits along x-axis. First to find out x limits along x-axis. So here this line along x-axis, this is the procedure. Now here x equals to 0. Up to the region is this line. This line is nothing but x equals to y. Then finally y limits here is 0 to infinity. Y is 0 to infinity. This is very simple method. Very simple method. Change the order of integration accordingly using the given region. Using this region, now find out the limits. Now we will evaluate. Now second step is also completed. First find out the region of the given double integral, then finding the limits, then finally evaluation of integral. So in this integral, y is x to infinity, x is 0 to infinity. This is the given problem. Now change the order of integration. Here in this method, first integrate with respect to x, then with respect to y, then integration with respect to x. But here we are changing the order of integration. First with respect to x, then with respect to y. Already we discussed the limits, x is 0 to y and y is 0 to infinity. First integrate with respect to y. First with respect to x. Here there is no x terms, directly integral dx. Remaining terms are separate x terms and y terms. Integral dx is x, limit 0 to y. So first put x equals to y, then x equals to 0, you will get y here inside y. So you will get y into e power minus y by y, this y and this y cancel. Integral y is 0 to infinity e power minus y dy. E power minus y integration is minus e power minus y, limit 0 to infinity. If you put y equals to infinity, e power minus infinity, e power minus infinity with a negative sign, minus. Now already minus here, minus or minus plus. If you put y equals to 0, 1 e power minus infinity is e power minus infinity is 0, then plus 1. So finally you will get 1. Now double integral with x is 0 to infinity, y is x to infinity, e power minus y, y dx dy equals to 1. In the similar way, we will discuss another problem. Evaluate the integral by change of order of integration 0 to 4a x square by 4a to root over 2 into root over ax dy dx. So now if you observe the variable limits in terms of x, that's why this is y. Now other variable is x is 0 to 4a. X is 0 to 4a, y limits x square by 4a to 2 into root over ax. Now we will evaluate this integral by using change of order integration. First we will locate the region. What is the given region? What is the given region? So now if you observe, the region of integration is bounded by y equals to x square by 4a. Upper limit is y equals to 2 into root over ax. Then x is 0 to a and x equals to 4a. Now squaring on both sides, this one second term, squaring on both sides and rewriting the first term. This is nothing but x square equals to 4a. This is y square equals to 4ax. Now what about the region? Now this is x. Sorry, I will write here. X, y. X square equals to 4ay is a parabola. Y square equals to 4ax is a parabola. And the point of intersection is, we will discuss later. Clearly, this is 4a, 4a. I will explain. And 0, 0. So the combined region is this one. This is the region between two parabolas and x equals to 0 to 4a. So then first we will find the point of intersection. Very simple. X square equals to 4a and y square equals to 4ax. Now from this one y equals to x square by 4a, x square by 4a. Now substitute x square equals to 4a in the second equation. Then what happened? X square by 4a whole square equals to 4ax, and x square whole square is x power 4. Here 4a whole cube into 4a is 4a whole square into 4a is 4a whole cube. Now, if it goes to left hand side, x is that common term, x into, here, this is small mistake, this is 3. X cube minus 4a whole cube equals to 0. If you simplify x equals to, equating with 0, x equals to 0 and x equals to 4a. If you substitute x equals to 0 in this expression, y becomes 0. X equals to 4a, y becomes 4a. Now, point of intersection is 0, 0, first point of intersection. Other point of intersection is 4a, 4a. First point of intersection is this one. This is O. This is another point of intersection. I will show in this diagram. Now, this is first x square equals to 4ay. Now, this is y square equals to 4ax. Now, point of intersection is, first point of intersection is origin, second point of intersection this one. This is the common region. So, first point is completed. Now, how to find the limits? Now, change of order of integration means here integrating with respect to x, then integrating with respect to y. For this purpose, first with respect to x, then with respect to y. X limits along x-axis. What is the first curve along x-axis? This is the curve, this parabola. That one is y square equals to 4ax. Y square equals to 4ax. So from this one, x equals to y square by 4a. Okay. From this curve to another parabola is x square upper one, this one. X square equals to 4a1. From this one, x equals to 2 into root over a1. Now, y limits already we discussed. Y limit here 0 and 4a. 0 to 4a. So, limits, x limits y square by 4a to x square by 4a to 2 root ax, ay. Then y limits 0 to 4a. Now substitute all these limits in the next integral. Now we will evaluate the integral. This is the given problem. Y limits x square by 4a to 2 into root over ax, x is 0 to a. Now change the order of integration by change of order of integration. Now first x limits, then y limits. X limits already we discussed. Y square by 4a to 2 into root over a1. Now y limits 0 to 4a. Now separate the x terms and y terms. So here there is no x term, only dx term, dx. Now this is dy. Integral dx equals to x limits y square by 4a to 2 into root over ax into dy. Now so first substitute 2 into root over ay, then substitute y square by 4a. Now integration with respect to y. Root y equals to integral root y equals to root y dy equals to y power 3 by 2 by 3 by 2. Because y power 1 by 2, x power n, integral x power n dx equals x power n plus 1 by n plus 1 using this formula. Y power 3 by 2 by 3 by 2, 2 into root a. Now y integration is y cube by 3, 3 4s are 12a. Now substitute the limits 4a and 0. First put y equals to 4a. 4a whole power 3 by 2. This is constant term. This is constant term. In place of y, substitute 4a whole power. 4a only whole power 3 by 2. Here 4a whole cube. If you put a y equals to 0, this term becomes 0, this term 0. Now we will simplify this term. Here 4. Now observe. 3 by 2 can be written as 4 by 3. 2 into 2, 4 by 3. Here root a into a power 3 by 2. Root a means a power 1 by 2. A power 1 by 2, a power 3 by 2 is nothing but a power 4 by 2 is nothing but a square. So this term is a square. Root a into a power 3 by 2. Here 4 power 3 by 2. Here 1 4 cancel. Okay, later we will cancel. 4 cube Here a cube, 1a cancel, a square by a square, a cube, a is a square. Now simplify. Here if you observe, here a square, here also a square is the common term. Here denominator 3, here also denominator 3, remaining terms. Here 4 power 1 into 4 power 3 by 2 is nothing but 4 power 5 by 2. Here 4 cube, 4 cube by 4, 4 cancel, already 3 is common term. So 4 square. 4 square, here 4 power 5 by 2 can be written as 2 square whole power 5 by 2. Now 2 cancel, you will get 2 power 5. This is 4 square is nothing but 2 square whole square is nothing but 2 power 4. Now this is a cube by 3 into 2 power 4 is the common term, 2 minus 1. 2 minus 1 is known. 2 power 4, that is nothing but 16 a square. 16 a square by 3 is the answer. 16 a square by 3 is the answer. Okay, if you have any doubts, ask me through my email ID and WhatsApp number. Thank you very much. Meet again in